Hi everybody. Last time we were together we talked about probability from chapter 4 in the book, and in class we went through and we discussed some of the information about that from sections 4.1 and 4.2. Today I want to finish up chapter 4. We're going to talk about a thing called a probability distribution. And in our book on page 162 there's an example, Wagner Investments, that we're going to use as the basis of our discussion. Now first of all, if you notice, we have a chart here, and it has X, which is a random variable, and all of the possible values for that X, and then the frequencies. Now, if you recall, this is called a frequency distribution, and it's a frequency distribution of a discrete random variable. Now, to take that frequency distribution and turn it into a probability distribution, you do nothing more than go ahead and turn the frequencies into probabilities. So for this particular example, a value of 0 has a probability of 120 over 300, which is 0.4. For a value of 1, we have 72 over 300, which is 0.24. For value of 2, we have 30 over 300, which is 0.1. And finally, a value of 78 over 300, which is a 0.26. Now, if you recall, last time we were talking about whenever we had probabilities, we were going to have the sum of those probabilities adding up to 1. Now, this is called a probability distribution. It's nothing more than a chart. It has my random variable. It has all of the possible values of that random variable, and it has the probabilities associated with it. And anytime we're talking about a probability distribution, we're talking about nothing more than that type of a chart. Now, the next thing that we talk about in section 4.3 is a thing called expected value. An expected value is nothing more than taking the X value, multiplying by its probability, and adding that all up. And that's what this formula says. The expected value of X is equal to each one of the X's times their probability added up. Well, if we do that here, 0 times 0.4 is 0. 1 times 0.24 is equal to 0.24. 2 times 0.1 is equal to 0.2. And that 3 times 0.26 is going to be equal to I was taking a look at something. 18, carry the 1, 6, 7.78. And when we add all of those up, we end up getting a 1.22. Now, what does that mean? The expected value is nothing more than the average of this frequency distribution. It says that on average, you're going to have a value of 1.22. Well, the other thing that we want to talk about, and this would be pretty much the same thing as a mean. It's the average. The next thing we want to talk about is our variance. Now, the formula for variance that you have in the book is found on page 162. And it says that variance is equal to the summation of X minus your expected value. You're going to square that. You're going to multiply it times the probability of that X. Now, actually in the book, it gives you the standard deviation, which is nothing more than the square root of this. Fortunately, there also happens to be another formula, and it's sort of an algebraic shortcut to this particular one, and it's it's written as follows. It says that variance is equal to, take your x's and square them, multiply that times the probability, and then subtract off the expected value squared. And actually, if you think about it, that's a much easier way of doing this than if you were to go through and use this particular computation for every single one of the x's. So let's take a look at this. X squared times the probability here is going to be 0, because I've got 0 squared times 0.4. Here I have 1 squared times 0.24, which is equal to 0.24. Here I have 2 squared times 0.1, which is equal to 0.4. And finally here I have 3 squared times 0.26. And I guess here we actually have a little bit of a computation. This is going to be equal to 9 times 0.26, which is going to give me 54. Carry the 5, 18 plus 5 is going to give me a 2.3. And so whenever I add this up, my summation of x squared p of x, I'm going to end up getting, I thought that they were going to have this in the book, but they don't. If you go ahead and you add this up, you're going to have 8, 2.98. Now we're going to subtract from that this 1.22 that we got over here, squared. And finally, what we learn is that our variance is going to be 1.2213 squared. That's my variance. My standard deviation is going to be equal to the square root of that. Or just the 1.2213. Now, these are some of the things that we have to know whenever we're dealing with probability distributions. We've got a thing called covariance, and we also have a thing called correlation coefficient. And we're going to talk about those in class. But in order to do your assignment for Tuesday, you're going to want to go through and be able to do these computations. I hope you have a great rest of the weekend, and I'll see you next time. Questions? Email me.